Rotary Position Embeddings made attention scores position-aware, but the value a token sends stayed identical no matter how far away it's at. RoVE, posted to AR14 as 2606.11275 on June 9, 2026 by researchers from the University of Amsterdam and MIT CSAIL, fixes that with 0 new parameters. Over the next few minutes, we will unpack how rotating value vectors works, what it does to GPT-2 at 124 and 354 million parameters, and why it reframes attention as convolution. Let us start with the core idea behind rotary value embeddings. Here are the essentials of rotary value embeddings in plain language, what it is, and why it was introduced. RoVE applies the same rotation matrices RoPE already uses on queries and keys to the value pathway as well. It adds no learned weights, so the change is parameter-free and drops into existing attention with almost no extra cost. Standard RoPE leaves values position blind. A token sends the same message regardless of distance. RoVE makes the kernel offset indexed, so the rotated value depends on the gap between query and key, finally making the value pathway distance sensitive. The authors show RoVE turns attention into attentive convolution, combining content-dependent weights with an offset-dependent kernel. In matrix form, it becomes a block-toplets mixer that couples token routing with channel transformation across the sequence. The team trained GPT-2 models at 124 million and 354 million parameters. RoVE delivered consistent gains over RoPE on few-shot in-context learning, out-of-distribution perplexity, and long-context retrieval, with the clearest wins on tasks needing long-range aggregation. Now, let us look at why rotary value embeddings matters in practice. Here is where rotary value embedding shows up in real products, teams, and decisions. We think the headline is not the accuracy numbers, but the zero-parameter price tag. A reported 63% drop in out-of-distribution perplexity at 4K tokens, with no added weights, is exactly the kind of free lunch teams should test before reaching for bigger models. RoVE claims to unify formulations across vision, robotics, and language. Our take, that cross-field framing could outlast the GPT-2 results because a clean convolution view of attention gives researchers a shared vocabulary that travels beyond any single architecture. These results stop at 354 million parameters. We would caution against assuming a reported 35% retrieval improvement transfers cleanly to multi-billion parameter models. The thing to watch next is replication at scale, where RoPE quirks often behave differently. Because RoVE is a drop-in tweak, the risk is teams flipping it on everywhere without measuring. We recommend treating it as a hypothesis to validate on long context workloads specifically, since that is where the paper says the benefit concentrates. Let us recap the key takeaways on rotary value embeddings and what to do next. The core idea is simple. Apply RoPE-style rotations to values, not just queries and keys, adding zero learned parameters while making the value pathway aware of relative position. RoVE reframes RoPE attention as attentive convolution, replacing a shared value projection with an offset indexed kernel that forms a block-toplets mixer across positions. On the 354 million parameter model, the paper reports an 11.5% in-context learning gain, roughly 63 to 64% lower out-of-distribution perplexity, and a 35% retrieval improvement on ruler. RoVE landed on AR14 as 2606.11275 on June 9, 2026, from Garcia Castellanos, Weiler, and Beckers, spanning the University of Amsterdam and MIT CSAIL, validated so far at GPT-2 scale. If a parameter-free rethink of attention is the kind of idea you want explained clearly, this channel is built for you. We turn fresh AI research into plain language breakdowns every week. For deeper guides, structured courses, and certifications, head over to standarity.com. Subscribe, and we will see you in the next one.